So the strain energy is important in material science because there's situations we're going to look at later on in the term where we're going to calculate the strain energy. So for example, when we talk about plasticity, we're going to be talking about dislocations moving through the material. And one of the things we're going to calculate is the stress field around the dislocation. You can imagine if the dislocation is, say, an edge dislocation is like an extra half plane of atoms in the lattice, that's going to distort the lattice. It's going to cause a strain field. It's going to cause a stress field, and it produces a strain energy. And when looking at the motion of the dislocations and looking at strengthening of, say, alloys trying to make material stronger, the strain energy associated with the dislocation is one of the things we're going to look at. Okay? Another place it comes up is in fracture mechanics. In fracture mechanics, typically you're looking at stresses around a crack, and you've got a crack in the material and you're, say, pulling it in tension. And for the material to fracture, the crack has to grow. And so the crack growth requires some surface energy. You're creating more surfaces, so there's some surface energy required. And the place that surface energy comes from is the release of the strain energy in the material surrounding the crack. So as the crack grows, the material around it releases strain energy, and you need to be able to calculate the strain energy. So there's places further along in the class where we're going to use this concept of strain energy to calculate something about material properties. So I'll just say in plasticity, we're going to calculate the strain energy of a dislocation. And in fracture mechanics, we're going to look at the strain energy released when a crack grows and forms new surface. Oops. Okay, so this is going to come up later on in the class, the strain energy.